live. So, good morning, everyone. My name is Jesse, and I am with Exploring by the Seat of Your Pants. For those joining us for the first time, we are all about bringing conservation, adventure, and science into classrooms around the world. And we are really excited today because we are doing something very different for us. We are highlighting a program specifically to a certain age group and in a certain country of Canada. We're all from Canada today. In fact, specifically, we're all from Ontario today, which is really exciting. Right now, we've got 3 classes and a 4th just joined from across Ontario. We're expecting a few more over the next few minutes, so we'll try and get them in soon too. But yes, I'm going to give them a chance to say hi. So let's begin. We've got Mr. Peters' grade 4 through 8 in Whitney, Ontario. Hi, guys. Hello. Hey, welcome in. We've got Miss Louise's grade 6s in Cambridge, Ontario. Hi, guys. Hey. We've got Mr. Hergot's grade 5, 6s in Toronto, Ontario. Hey, hey, welcome in. Nice Blue Jays cap. And then we got a mystery class that just joined us a second ago. So we'll welcome them in too. Hi, guys. Welcome in. All right. We'll find out who they are in a little bit. But of course, the reason you guys are all here today is for our speakers. So let's keep your mic muted, classes, guys. There we go. Thank you so much. The reason we are all here today is for our speakers. We're joined live in London, Ontario by Dr. Parshati Patel. So she is an astrophysicist at Western Space, and she's going to talk a little bit about her career. She's done many sessions, I can speak English, with us over the last couple of years. So we're thrilled to have her back. But today she's also going to be highlighting the Junior Astronauts program. So it is an initiative of the Canadian Space Agency where they are encouraging kids to take part in some amazing activities online in an effort to win some really, really cool opportunities. I don't want to steal her thunder. So without further ado, I'm going to turn it over to Dr. Patel. Thank you so much for joining us and take it away.
Thank you, Jesse. Hi, everyone. I'm really excited to be here talking actually about adventures of an astronomer, but at the same time also about the Junior Astronaut Project, which highlights a lot of different careers in space. And so we'll go through them today. And you know, I'll highlight one of the activities, which I find it pretty cool. And I hope you guys will be able to, you know, if you haven't already done the activity, to do the activity with your classmates and showcase what you have. So let me share my screen and we will get started. Awesome. So I can see that you guys are able to see. All right. So we're going to start by talking a lot about what an astronomer does. And I'll give you an example of myself. And then we'll talk about why we need junior astronauts. Canada does need indeed a lot of different professions in the space industry in the next few decades. And you guys are going to be the ones who will be filling those positions. So let's get started. I always like to talk about how I got inspired to study astronomy. So astronomy is studying, you know, objects in space, including planets, stars, galaxies, how the universe began. When I was very, very young, almost 10, 11 years old, I got to visit a planetarium. When I was visiting a city called Mumbai. It's one of the biggest cities in India. That's where I grew up in India. And when one of those visits, I was actually able to visit this planetarium that you see right here. And I had not seen a lot of the, you know, constellations, did not know about them. The night sky, it was pretty polluted from where I was living. So when I got to see and learn about all these different constellations, I actually was amazed how much there is, you know, other than just the moon or occasional planets that we see in the night sky. And there's so many things out there that I did not know about. And so at the end of the planetarium show, I asked a lot of questions and you know, obviously they ran out of time. So I asked questions to my parents as we were walking out, and they both were not familiar with space. So what they ended up doing was we went to the gift shop and they just got me like a lot of books. Now, this is not the collection of my books that I had at that time, but just an example of how I ended up collecting a lot of the books, just, you know, with simple questions I had. What are planets? What are stars? How do they form? What are galaxies? And just those simple questions kind of got me intrigued about, what is out there in space. One of my aunts who lived here in Canada heard about, that I'm now kind of obsessed with space and ask everyone a lot of space questions and or for books for any occasions. So when she was visiting me, instead of buying me a book, which normally what people did, she actually bought me a small telescope, and this is not the exact same telescope, but it's similar size to what I got. And then, I took it to my terrace in the home, and I, pointed it to the moon. And I was so excited that I was able to do that myself and look at the craters on the moon and different features. And then I was able to point it to Saturn and Jupiter. I think that was the point where I said, oh, this is a cool, this would be a cool job if I could do someday. And, just look at these planets, trying to understand what they are, try to look at the sun, and understand how all the stars are forming. So I ended up getting really intrigued by stars and planets. So when I decided to study astronomy, I said, I really want to look at the formation of stars. And so if we look at where these stars, like our sun and other stars that we see in the night sky, form, I started studying what we call stellar nurseries. So here are two examples. These are pictures of two different kinds of nurseries. And basically, these are areas where you can find all the ingredients that a star needs in order to form. So on this image, you can see that there's a lot of dust and gas. So you can see that there's wind that's blowing away the dust and the gas that's around it. And all of these dots that you are seeing are actual young stars being formed. So, thanks to our technology that we have right now, we're able to take these amazing pictures and see these stars forming in action. And, Orion Nebula right here is my favorite nebula. I love it. Not only it's beautiful, but it's also my favorite because it has something that other nebulas don't, which is actually these really nice tiny pictures of what we call proplyds. So these are protoplanetary disks. What it means by that is that a young star, when it's forming, there's material around it that is, kind of getting to the center where the star is forming, and it comes in very many different shapes and sizes, just like, the formation of each of the stars is very unique. So if you look at these pictures, what you're seeing is, for example, here, there's a tiny star in the middle, but then the disk around it is pretty, almost like a donut shape. Okay, but some of them, you have the material is being blown away. So for example, this one right here, you have the star in the center, and then you have all the dust and gas that is being blown away by the wind. And so there are all these unique pictures that Hubble has taken in the 1990s, and we have around 200 of these pictures. So here are the sample of some of the pictures, and you can see how different they are. And it makes an interesting question to ask is, how do these stars form? Is there a unique process that is dependent on each star and its location? Is there something that's constant among these stars? And how they form. So me as an astronomer, in my master's and my PhD, when I was studying, I actually got to look at these stars and the disks around them and how they formed. So I will give you a snapshot of what an artist's rendition would look like. So if I were to go, near a star, what would it look like? Obviously, in our lifetime, I don't know if we'll be able to do that, but if we could, that would be amazing. We, however, have a lot of data from these kinds of regions, especially the Orion Nebula is very well studied. So I will show you a short video of what it would look like if you were to hop in a ship and drive through the Orion Nebula. So let's get this video started. As you can see, you are driving through the Orion Nebula, and all of these stars, you can see on the top, on the side, what you're going through now is the dust and the gas that would eventually form these stars. You're also seeing, soon there will be on your left-hand side of the screen, you will see a very, very small star that has its, material being blown away, for example, right here, blown away. And you can see there is wide variety of stars that you are seeing, and it's so beautiful. But at the same time, it gives us a lot of information on how to actually study these stars. So what I did for my PhD was I took just 4 stars that I was studying. And, if I were to cut it, like I would take a donut and cut it into half and look at from the side, this is what it would look like. In the center, I have a star. I have a lot of gas around it because the star is so massive and so hot that the material around it actually evaporates, and all the dust is gone. You just have gas around it. And then as you go further and further, things cool down, and you start getting pebbles, and you start getting rocks that eventually form planets. So how would I, as an astronomer, study this? Obviously, I cannot go like that video. We don't yet have the technology. However, we have things like amazing telescopes here on Earth that allow us to study these, and in the sky. So I personally actually got to use the Canada-France-Hawaii telescope in Hawaii, and take images and pictures, as well as the spectrum of the star. And what I mean by spectrum is actually just collecting light from the star. And you all would have seen a rainbow, right? After rain, the droplets acts as a prism, splits the light into these lovely rainbow colors. So I, as an astronomer, also use that similar technique and take the light of the star and split it into all of these colors. And when we do, we see these amazing, tiny little black lines when you do. So here's an example. I've put together a lot of these different stars, and that rainbow colored image that you would see, and you see all of these black lines right here. These are actually really, really interesting lines because they tell you a lot about what kind of elements that are present in and around the star. And those are like fingerprints. So you know how every one of us have this really unique fingerprint, and we can figure out whose fingerprint that is just by understanding what it looks like. And so we use the same technique in understanding what elements are present in these stars as well. Now, I have data, from these telescopes, and I understand how these stars are forming using the physics and the math. But obviously, we need to recreate these somewhere to be able to understand what we see from the stars and what we are trying to understand if those are the same. So I actually, during my PhD, got to use a computer model that looks something like this, where I'm recreating a star and I'm recreating the disk that is around it. And then I try to figure out what I see from the light that is in these images right here, and the same kind of regeneration in the computers, if it's similar or not. So it's pretty unique that we have the technology to recreate the stars and in what we see in the universe in our computers now. And so we're able to compare what we understand and keep growing our theory of what and how these planets and stars are actually forming. So I was very lucky to be able to understand this very tiny aspect of a very, very large universe. And try to understand how these disks around these stars are forming. So that is kind of an overview of what me as an astronomer did in my master's and my PhD. What is unique is that space is very interdisciplinary. And what I mean by that is you could be an engineer and be part of space. You could be an astronomer and be part of space. You could actually be, you could have studied medicine and be part of space, because there's humans, when they go to space, there is a lot that happens to our body, because the environment is very different, because we're no longer on Earth. So, when you look at all those different things, the careers in space are very varied. So you could have varied amount of interest and still be part of space in many ways. And this kind of segues into how the new junior astronaut campaign that the Canadian Space Agency has launched talks about the different careers that a scientist or an engineer, a kinesiologist, a physiotherapist, all of these different careers that people have can actually relate to space. So Canadian Space Agency is actually looking for junior astronauts for their next summer camp. So they are hosting a summer camp that is going to be all about training the next generation of astronauts, which is all of you guys, and as well as showcasing all the different experts that Canadian Space Agency and or the space industry needs in order for us to get to the moon. So I don't know if you guys have heard, but Canada is part of the Lunar Gateway project that is led by NASA. And for that project, we will be launching a mini space station. So we have one international space station that is currently orbiting Earth. We're making a mini version of that to send around the moon. And that will be, inhabited by astronauts, not the entire year, but partially, maybe 3 or 4 months a year. And because Canada is part of it, isn't going to contribute to it, we will have a chance to send a Canadian astronaut to the Lunar Gateway and then onto the moon. And so as you can see in the picture, they're actually looking for the next generation of astronauts. And to do that, they are actually they have created a bunch of activities that, some of you have already tried out. So if you try out 3 activities, one from each different stream, you can actually qualify to be that astronaut, junior astronaut who gets to go to the Canadian Space Agency in the summer and get trained like a real astronaut at the space agency, which is, I think, is the coolest part. It didn't exist when I was young. I wish it did, but you guys are in the correct age group and correct spot to be able to do this. And I'm sure Jesse agrees with me. He would love to do this as well if it was available.
Absolutely.
Right?
I wish I was as old as you kids.
I agree. I wish I was too. Unfortunately, I am not, but I'm hoping that one of you guys get the chance to actually do this. And so in order to do that, what they would like to also highlight during this process is all of these different careers that you could be a flight controller, an astrophysicist like me, you could be an engineer, mathematician. They need all of these different kinds of, careers to be able to support the astronauts when they go to space. In addition to being an astronaut, they generally look for things that is STEM related, so science, engineering, technology, and mathematics. If you have that background, you could be an astronaut. All right, so one of the activities that we'll talk about today that will, if you do it, qualify you or your school to actually apply and get an astronaut visit and or a space expert from the CSA to visit you. So that is super cool. So we will be doing that today. And once you finish the activity, you will be qualifying for it. So this activity is one of my favorites. It's a patch maker. Every crew member, every astronaut that goes to space has a patch, and a patch defines a lot of things. So here's a patch for the junior astronauts, and you see this is a campaign where they're going to be sending a Canadian to the moon. So it has a Canadian astronaut right here with the flag of Canada, moon in the background, and the campaign name. So if you were to make a patch, which, if you haven't already done it, I would highly suggest you to do that. Your patch needs to contain a few things. Your name, right? Write this one up here, which is David Saint-Jacques patch, this agency name. So you can come up with you can add this Canadian Space Agency, and a meaningful image. And what we mean by that is think about what mission you would want to go to. For example, I'm an astronomer. If I had the technology, I would want to go to the nearest star and check it out. So I would have a star in my image, and probably I need a spaceship, so I would have a spaceship in my image as well. So that would be my patch. But you have to think about your own personal goal of what you would do if you were an astronaut. And I will give you an example of the David Saint-Jacques patch. And his patch actually contained a few things. His had this particular star here is actually a North Star. And it has Earth right here, a few other smaller stars, and this lovely trail right here. And I'll break it down what each of these means so you can see how detailed of thought has gone into making this patch. So what they have done, this North particular star, David thought that, North Star is generally the one that guides the explorers to go. So, if you get lost on camping trip, you look for the North Star to find your direction where you are. So he used that as a metaphor for guiding explorer. And he's an explorer in space as a representative of Canadians. The trail that you see right here actually represents our pillars of innovation. So the red color actually means energy and passion, orange means creativity, white is for science, and blue is for international collaboration. And then obviously there are 4 stars. This actually means that, you know, even though he is the one who's up in the space station, there are hundreds of people here on Earth that actually help to make his, you know, time up there most productive, make sure he's doing the science, make sure he's healthy. All of those, you know, it's a pool of a lot of people's talents that actually make his mission successful. And then last but not the least, looking back at Earth. So if you haven't visited Exploring Earth site on the Canadian Space Agency, you should, because he took a lot of pictures during his time on the International Space Station. And it was pretty cool because all of those images showcase how fragile Earth is and how important it is for us to ensure that we are protecting our home planet. So that is his patch. And so I would actually suggest you to think about your own mission and design your own patch. And you know, I want to show you guys some of the examples of the patches that have been, you know, created in the past. My favorite is actually Julie Payette's patch, but you can see there are tons of different Canadian astronauts and their patches here. There's some more in the next one as well. And I want to point out one of those. So for example, Dave Williams' patch right here, when he went up onto, you know, STS 118 expedition, he was actually servicing the space station using the Canadarm. So you can see that he actually used Canadarm here, and you know, you can see that he was servicing the International Space Station with the Earth in the backdrop. So you know, it's the time where astronauts get very creative about what their mission is like. So I would actually suggest you to think about your own patch and what you would have, but at the same time, you saw that not only there were individual astronaut patches, all astronauts actually wear 2 patches on their blue suit. So if you have noticed any astronaut that has gone to space, next time if you see David, have a look, they actually wear 2 patches. One is the patch for the crew that they're going to join when they go to the International Space Station. And the second patch is actually for their own mission that they're going to conduct. So for a crew patch, you would have, here's an example of the Expedition 58 that David Saint-Jacques was part of. And so his patch crew or mission patch was actually included not only the crew member names, mission number, and also, you know, what the creative way of saying what their mission was about. So in this particular patch, you can see that again, that they have the compass rose, which is North Star with a lot of different directions. The mission was about Earth, and also they had the International Space Station in the background because they were looking back at Earth. So, you know, again, very creative, similar idea to his individual patch, but at the same time encompassing the idea of all the crew members' mission, not just his in this particular patch. So I'm going to also task you, in addition to making your own personal astronaut patch, I would actually task you to make something like this, where, you know, you have your whole class patch. So I would, you know, challenge you to make one for your entire class, discuss what your goal is going to be for the year, come up with a creative way of representing that, and put your teacher's name in it, as well as come up with a really cool name for your class, and put it on it in addition to your teacher's name, and put it in on your door. When you enter every day, you know what your mission for the entire year is going to be. So I'm going to challenge you to do that. I know some classes have already done this. I'm really excited to look for those particular mission patches with your crew members, which is going to be your classmates in this case. So thank you. And I'm hoping that you guys are going to take part in the Junior Astronaut campaign, and hopefully one of you is going to be that astronaut that's going to go to the moon.
Very cool. Well, thank you so much, Dr. Patel. If you want to leave that screen up for just a second so people can get some stuff down from it. I'm also going to share all that information with our classes when we're done. A lot of you have already signed up to Junior Astronauts. You know about it through our work ahead of time, but we'll make sure that you guys have links to that site, to David's mission, and to some of the other amazing activities, not just that we're covering today, but that we're going to be covering in our follow-up sessions, not just in December, but throughout the year with Dr. Patel and the team at Western Space and the Canadian Space Agency. So yeah, thank you so much. I also loved watching some of you guys. I mean, in addition to attentive kids watching in, we had some kids like frantically making patches, it looked like. So that's awesome. And I know we passed along the link to be able to make a patch. I know it was only a few days ahead. I know some classes have worked on some patches. So if you guys want to come up in question period, like it's a little different than a usual session. You're welcome to come up and ask questions about, Dr. Patel's work as an astrophysicist, some of the amazing stuff going on in Western space. If you want to find out a little bit more about junior astronaut, you can ask about that as well, or about the patch program. And so the world is your oyster, guys. We've got a few groups watching on YouTube as well. So if you guys want to type in your questions, please do, and I'll happily share them. But yeah, Dr. Patel, if you want to come out of screen share now, we'll come back to you, and then I'll go through our classes. We also had a bunch of classes join us while we had, after we'd begun. So welcome to the team at General Career School in Toronto. We've got Miss Smith, Miss Cleland's class in Mississauga, and we've got Miss Heritage's class in St. Catharines. So I know some of you have some various technical difficulties, and I'm sorry for that. We're going to try and take questions from you too. But yeah, with that said, let's dive in. I want to start with Mr. Peters' class in Whitney. If you guys want to kick us off with a question or to showcase anything you guys have created, come on.
Hello, we started making our patches, and so I'm just gonna show you some of the patch designs that we've made so far.
Cool. Is that a personal? These are personal patches, not class patches then?
Yes, correct. We started with our personal patches.
Nice. Very cool, guys. Holy,
I love how so many people want to go to Saturn. That's one of my favorite planets, so I'm seriously excited.
Yeah, I really love that. And so way to go to you guys for being so creative, but it was so nice, Dr. Patel, when you mentioned that it doesn't need to be a place that we've gone to already. It doesn't need to be the moon. When we highlight space talks, it's been all the planets, it's been other stars, it's been Europa, the moon of Jupiter. Like there's so many amazing destinations out there. So way to go, guys. Did you have a question right now too about anything, or do you want to dive in later, or your call?
No questions right now from us.
No questions right now. We'll come back in a minute then. That's awesome, guys. All right. Let's go to Mississauga. So Miss Smith, Miss Cleland's class, Bristol Road. Let's see.
No questions right now. We'll come back in a minute then. Awesome, guys.
Hey, Bristol Road.
Let's go to
A little delay. Okay, so with Bristol Road, there's a bit of a delay. So I'm going to send them a message online. Oh, there we go. They got in a question online. At what age did you decide to work in space, Dr. Patel?
So I was around 14 years old when I decided that this is what I wanted to do. I did start getting obsessed with space at the age of 11 or 12. So it took me a couple of years before I decided that this is what I'm going to be doing for life.
Very cool. All right. Yeah, let's head to Miss Louise's class in Cambridge. If you guys want to come up with a question or comment or anything else.
We have 4 students in line with 4 questions.
Holy, okay.
Awesome.
How about we take 2 and we'll come back for the other 2 in a little bit.
Okay.
Perfect. Go for it.
So they say sometimes if you're in space too long, your spine shrinks or your bones shrink a bit. Does it hurt or do you not feel it?
So yes, being in space. So I've not been fortunate enough to be in space, but what we hear from the astronauts is that obviously it's very taxing on your body because it's very different. We do see that the bone and muscle mass loss happens during their time up in space. You know, when you see astronauts that just land, they're always carried by people. Generally, you know, they feel the fatigue of being up in space. Their body is trying to now adjust to Earth. And so they're kept in quarantine for a bit. From what I hear is you know, when David came back, he was a little sick when he came back. So they brought him out of the capsule and they escorted him, you know, for him to recover a bit before he was able to make a public statement to the reporter. So, you know, you do feel a lot of the changes that are happening to your body. And this is why we need scientists to be studying how our body's affected and how we can combat that if we want to go to places like Moon for a long time, as well as from Mars, which is going to be a longer journey. And so we're using using the expertise of these medical field scientists to understand, you know, how we can combat this. But they definitely do feel the effects of these. Yeah.
Yeah. One of the coolest studies that you guys might want to check out, there are two twin brothers, Mark and Scott Kelly in NASA. And so they spent many years combined in space, but one of them went up for 1 whole year. And so they charted the two brothers over that time to see the changes in the body. It's quite considerable. It's quite interesting what space does to you. And so again, as we're planning longer missions, that'll be a really neat thing to check out. All right, back to Ms. Louise's class. Come up for that second question. Go for it, guys.
So people are saying, like, are you actually, like, SpaceX and NASA gonna send people up for, if they pay, to up to space and back down?
Yeah, so there are private companies like SpaceX and, you know, Virgin Galactic. There are a lot of different companies that they're actually starting to take, I think the first tourist flight to space is scheduled for the end of next year. We don't know if it's going to go through, but people have already actually paid for tickets, and it's not a small amount. People have paid for those, and they're hoping to get a chance in next couple of years to be able to go to space. However, this is not like what the International Space Station is like. International Space Station continuously goes around Earth, and you know, we have astronauts that go up very so often, but not as frequent as what tourists are going to be doing. They are going to be taken up to the edge of the space where they're going to feel the weightlessness and, you know, feel what it's like to be in space for a few minutes before they're going to be back down. And because it is, you know, just a very, very new thing that they're doing. It also costs a lot, and it's going to be a very, very short amount of time while they're going to be up there. But it is definitely a thing that is in progress. So by the time you guys become adults, like, I'm pretty sure there are going to be like regular flights to space that are happening, and we can pay and experience the space.
Yeah, very cool. I also want to highlight now this new wave of space tourism is going to be a little bit less. We did have a few space tourists go up in the 2000s. They spent over $200 million to do it, which is a little out of most of our price ranges, but we did have 7 tourists, including a Canadian, went up to the International Space Station during that time. So there's a precedent here. We've done it before. We're going to do it again better.
Yes.
Awesome. All right. So Miss Ayer's class, and just in general, the whole school there, it seems, if you guys want to come up, let's see if your mic's working. I know there's been some audio difficulties, but I want to get you guys in for a question. I know you guys also made patches, which is awesome. So right now, it's not letting me demute your mic, but if you demute it, which would be just a little button at the bottom left of your screen, then we'll take you in for a question.
Okay, can you hear us?
Yes, we're good.
Awesome. We wanted to say, as 3 classrooms together, hi, Jesse, and hi, Dr. Patel. Go ahead, friends. And we wanted to thank you so much. I would like to let Dr. Patel know that some students from my grade 6-7 class did some teamwork patches. So we chose to involve our patterning from math into a teamwork patch, and I'd like to invite them up to show their patches.
Okay, that's amazing.
Quick. So go up. You all come up, quick. Right in front of this camera.
There's just too many kids. It's so hard to get through. Nice, guys.
That's amazing.
So with that patch, no, the first one you showed, there were like drawn bits at the corners. So is the whole thing the patch with the drawn bits at the corners, or are they 4 different patches?
So they each took a part of the patch and then they put it together with their own pattern designs.
Nice, way to
That's
go,
amazing.
guys.
Yeah.
And
So hold them up first. Hold them up.
That's true teamwork.
Yeah, so that's worth noting too. So the 3 streams that junior astronauts are looking for are fitness and nutrition, teamwork and communications, and science and engineering. So we've got 3 streams that contribute to being an astronaut. Those are the activities they're looking for if you guys want to win a trip to that space camp. It's fantastic.
This is amazing.
Great job, guys. All right. Yeah, that's amazing. Did you guys have a question for Dr. Patel too, or did you want to show patches?
Have a question, my friend?
Yeah.
So Madame Vicky, can you pick someone from the back? Adam, come up quick. Super quick. You have to go quick. Okay. All right. This is Adam.
Hi, Adam.
Hi. Do you feel sick when you come back from space?
Do you feel sick? Do astronauts feel sick when they come back from space?
So it varies depending on the astronaut. In the past few years, we have seen that some feel very sick when they come back. They have a hard time adjusting, to the, obviously, first of all, the process of getting down onto Earth is grueling on their body. So when they come back, sometimes they feel nauseous. Sometimes they feel like they want to, throw up. Most of them are okay, just because they go through a lot of training to ensure that their body is trained for this. But it varies. It varies depending on the astronaut. Not always you get sick. So yeah, that's what we've seen in the past.
Awesome. All right. We had a class that was in for a minute and then their tech kicked them out, but I want to pass on their questions. They can watch us on YouTube. So Miss McLaughlin's class, joining us from St. Catharines, Ontario, wanted to ask, where did you go to school and what subjects did you take?
Yeah, so I took physics and astronomy when I was in my undergrad, and I did my undergraduate degree at the University of Toronto in Toronto. And I took a lot of physics, math classes, but I also got to take some cool classes like geology, geography, and as I said, space is very interdisciplinary. So I was able to take all of these classes and still get my credits for the physics and astronomy degree. I then moved to the University of Western Ontario, which is where I'm based right now, where I did my master's and my PhD in astronomy. But this time I was able to take a minor in planetary science and space exploration. So I was able to expand my study from just studying stars to actually learn about space exploration and the planetary science aspect of space.
Very neat. All right. Mr. Herget's class, if you guys have a question, go for it. Yes.
Hi.
Hey.
I made a mission patch.
Nice.
Wow.
So my question is, what are some of the effects of prolonged exposure to solar and cosmic radiation on the human body?
Great question, and I also loved your patch, and I can see that there is Earth on it, and I either it's a spacecraft, and okay, it's a spacecraft and tons of stars.
Yeah.
Amazing. So good question. Actually, how our body is being affected by radiation is one of the very key areas of research right now. And the reason why it's a key area is because we want to go to Mars, and when we are going away from Earth, we are putting ourselves outside this lovely magnetic field that actually protects us from a lot of the solar radiation that could be harmful to us. What has been seen in the past is the radiation can affect as deep as a DNA and an RNA level, which is, which actually allows us, when we multiply our cells, they can get damaged, you can get cancer. There are a lot of these effects that we are already seeing here on Earth, but would be multiplied into, extreme amounts if we were to be exposed to this radiation continuously for a very, very long time. Is in particular, she mentioned the study that was happening for the two twin brothers. One of the things that they did see that, their DNA generally is closed. The strands are generally not open, which when multiplied can actually create a lot of complications and have cells that can create cancer. And those were seen to happen when they were up in space, when Scott was up in space. However, it reverted back to what it was when he came back, which means our body is able to adapt and repair itself. However, you can imagine if he was there for a 3-year time span on Mars, that would not be the case because the radiation amounts would be higher and he would not have time to regroup. His body wouldn't have time to heal himself. And so we are actually currently looking for, a lot of ways to ensure that we are protecting ourselves when we're going to the moon and to the Mars. So really good question.
Very cool. All right, guys, what we're going to do is I'm going to take a few more questions from classes, and then we're going to wrap up by just explaining a little bit how you guys can submit these patches. But so many people created patches, so I want to make sure you guys know how you can go about that. But yeah, let's go back to Mr. Petrus's class. If you guys have a question now, you're welcome to come up. Go for it.
So we have a question. Teacher's just coming up to ask. We'll just ask what she studied. How long did it take to get to
How long did it take to get a job there?
working for the space agency?
Working for the Canadian Space Agency.
It's a really good question. I loved how you asked about how long does it take for me to get the education I did and then to a job. So it took me 10 years, actually 12 if I count my college, 2 years as well. So 4 years of undergrad, 2 years of master's, and 4 years of PhD. That's a long time to be an expert in the field I am. And then I actually transitioned into what I guess we call ourselves science communicators now. So my current job I got right after I graduated, but I actually worked towards this job since the start of my PhD. So it took me 4 years of learning the ropes of the job while I was doing my PhD, and then transitioned into my current position where my job is to communicate all the space science and technology research that is happening not only here at the Institute, but it's in general around the world. Bring it to students like you, bring it to, public in general. And I currently work for the Institute of Earth and Space Exploration. We're working with the Canadian Space Agency to bring the Junior Astronaut Program to Canadians across the world, I guess, because they would also be eligible if they are Canadian. But yeah, it took me, it has been 4 years since I've been working in this field now. So it's a pretty long time.
Awesome, good for you. All right, we're going to take those 2 more questions from Miss Louise's class because they had 4 to kick us off. So if you guys want to come up and wrap us up before we find a little bit more about the program, go for it.
Do you have to have any special qualifications in order to go to space? And
That's a great question. So you have to have a bachelor's degree in sciences or STEM, which I talked about: science, technology, engineering, or mathematics. So if you have any of those backgrounds, that's kind of one of the most basics. They obviously have the physical tests and stuff that you need to do, but in order for you, in terms of education, you have to have a STEM degree to be able to become an astronaut.
Awesome. All right. And then a second question for you guys. Go for it.
how do they choose who goes to space next? Like what astronauts?
That's a good question because we currently have 4 active astronauts, and Canada is a part of a large collaboration with NASA, ESA, JAXA. There are all these different agencies that send their astronauts, and so it depends on when the mission is available and then who is available to go. So right now, Jenny Saidi Gibbons, who's one of the newest Canadian astronauts, as well as Joshua Kudrick. Both of them are new, so they are still in training. David Saint-Jacques, as well as Jeremy Hansen, both of them are senior current active astronauts. So obviously they get picked first, and then the next phase will come when Jenny and Joshua would have a chance to go. So David has already been to space now. Hopefully it's going to be Jeremy next, though it depends on when the missions are happening and who gets to go when. Different countries have priorities based on the amount of contributions they make to the International Space Station.
Yeah, and as far as I know, every single mission, so because it's Roscosmos in Russia and then NASA jointly, send people to the ISS, and we're the main builders of it, there's always an American and a Russian, and then there's typically a third person from another space agency, yes. And they launch right now with SpaceX and some other things. We're looking into launching from new and fantastic places and back to the States. But for many years now, the only place that they can launch in the world is the remote desert in Kazakhstan, which is amazing. So Star City, you guys should look that up. It's really neat. And the rockets they put people on are surprisingly tiny, a little scary. But yes, very cool question, guys. All right, so fantastic all the classes for taking part and making some cool patches, some great questions, guys. Before we wrap up, Dr. Patel, so the kids have made these patches. Do they just go on the website of Junior Astronauts and submit them there? Is there a place to do that really easily? What do they do?
Yeah, so once you have done the activity, the teachers can actually mark that you have completed the activity when they register. So that will give you a chance to then be able to apply to go to the camp, as well as the teachers can actually apply to get a space expert or an astronaut to visit your school. And the applications will be taken in starting January. So look them up in the new year and you should be able to apply if you complete the 3 streams to go to the camp. So make sure you are completing an activity in each of the streams to qualify for it.
Outstanding. And for our classes too, again, I've already mentioned it, but December 3rd, December 10th, we're going to have other sessions with Western U talking about some other activities within junior astronauts. So check for our newsletter, which should be going out today. Sign up for those. If you guys want to take part in multiple sessions, we'd love to have you and trace your journey over this. And again, if you want to share your patches online, if any of your teachers have Twitter, if you want to just tag Canadian Space Agency, Western, and then explore by the seat of your pants, we'd love to have you guys do that. We want to see so many patches from all you guys. And so thank you so much for taking part in this very unique and special session with us today. Dr. Patel, as you know, what we do at the end of every one of these sessions, I'm going to demute everyone's microphone. And so boys and girls, if you guys could get ready to join me in saying a huge thank you to Dr. Patel for joining us today. You are all demuted.
Thank you.
Awesome, everyone. Thanks so much for joining us, guys. We really appreciate you guys being here. And again, look for some information. I'm going to send an email when we're done with some even more, and we'll go from there. Dr. Patel, thanks so much for being a part today.
Thank you for having me, guys. I hope you guys enjoyed making, if you have already done the patch activity. If not, I will task you to do it now. It's really fun. So
I'm going to get on making mine the moment I leave. All right, let's do it.
Awesome. Thank you. Take care.